Good afternoon, everyone. My name is Arjun Jilal, and today I'm going to talk about something that powers a huge portion of the world cloud infrastructure, something that CERN uses to analyze data from the Large Hadron Collider, something that China Mobile uses to serve 900 million subscribers, something that Walmart uses to serve Black Friday traffic spikes. That's something called OpenStack. Now, people have heard of AWS, Azure, and Google Cloud, but very few people ask, what if you want to build your own cloud? What if you don't want to pay millions in licensing fees to Amazon or Microsoft? What if you want to complete control your own cloud infrastructure? That's exactly what the OpenStack gives you. And by the end of this presentation, you're going to understand what OpenStack is and how it works and what it is incredibly good at, where it struggles, and whether it's right choice for you know large scale public cloud deployment. So let's dive into the very detailed explanation of the OpenStack. The OpenStack has already 30 plus projects. It was developed in 2010. 1 million plus deployments have been occurred. It has Apache 2.0 license. So let's get started. First question is what is the OpenStack? Uh, if we look deep into that, OpenStack is a free open source cloud computing platform. It was launched in July 2010, not by any software companies, but by NASA and the Rackspace. NASA needed a way to manage massive compute infrastructure internally. Rackspace needed a competitive cloud platform. They collaborated sourced their work, and OpenStack was born. In simple terms, OpenStack lets you take a bunch of physical servers, storage, and networking equipment and turn all of it into a single cloud. A cloud uh, where you can uh, where you can spin up virtual machines, manage storage, configure networks, and offer self-service infrastructure to users, all through a single API-driven platform. This is what we call as a infrastructure as a service. Instead of using AWS or Azure, you are literally building your own AWS using the OpenStack. Today, OpenStack is managed by Open Infra Foundation with over 60,000 individual members across 180 countries. It's an enormous community, over 1 million deployments and 30 plus integrated projects, as we seen in the introduction slide. So look at the timeline. 2010, founded by NASA and Rackspace. 2012, the OpenStack Foundation was formed. 2016, the Newton release brought over major scale improvement for larger scale deployments. 2019, rebranded to Open Infra Foundation to reflect a broader mission. 2023, the Bobcat release with a mature Kubernetes integration. And one more important thing is OpenStack uses Apache 2.0 license. That means it's completely free, no per VM charges, no per cost licensing fees, no annual subscription. You pay for your hardware and your team only. The software itself costs nothing. A single fact that changes everything about the economics of building a cloud. So this is called the OpenStack. Now let's we look into the architecture of the OpenStack. So this is the architecture of the OpenStack. It's a layered view. Think of OpenStack as a layered cake. Each layer has a specific job, and they all work together. And they all work together to create a complete cloud platform. Think of OpenStack as a type of layered. The bottom layer is the physical infrastructure. This is your actual hardware. Physical servers with KVM or Xen or VMware hypervisors running on them. Storage system, Ceph, NFS, ISC, SI network equipment with open vSwitch and the SDN protocol and a bare metal servers. This is the foundation that everything runs on. And the next layer is the core service. This is the heart of the OpenStack. Five key services live here. Nova manages compute, spinning up and managing the virtual machine. Neutron manages networking, virtual switches, routers, and firewalls. Sender messages block storage. Persistent disk for VMs. Shift manages object storage like Amazon S3. Glance manages VM images. The templates used to create the new VMs. Above that, the API and the identity layer. Keystone lives here. Keystone is the security backbone. It handles the authentication, issue tokens, manages user and the roles, and every single API in the OpenStack goes through the Keystone for verification. Then there is the orchestration layer. It lets you deploy entire cloud environment using YAML templates, YAML templates. Infrastructure as a code. Magnum manages the Kubernetes clusters on the top of the OpenStack. Uh, Mistral handles workflow and designate manages the DNS. And at the very top, the presentation layer. Horizon is web dashboard. It is a browser-based GUI for managing everything. The OpenStack CLI for command line users, and the REST API client for programmatic access. Every layer communicates with one below it through APIs. This modular design means you can swap out components, use a different hypervisor, a different storage backend, a different network driver without rebuilding everything from scratch. Flexibility of OpenStack is the biggest strength in the architecture. So these are the overview of the open OpenStack architecture in a layered view format. Now next we can look into the key components in detail. Now let me walk through each of the major OpenStack component individually because understanding what each one does is the crucial to understanding the whole system. So this is the key OpenStack components. First is the Nova, the compute engine. Nova is the most important. It's with multiple. It is responsible for launching, managing, and terminating the virtual machines. It works with multiple hypervisors such as KVM, Xen, VMware, ESXi, Microsoft Hyper-V. When you start a new VM, Nova takes the request and find the best physical host using its filter scheduler and launches the VM there. The filter scheduler is the intelligent. It considers available RAM, CPU, and the availability zones and the affinity rules when deciding where to place a workload. Neutron networking. Neutron provides software-defined networking for your cloud, virtual routers, subnets, floating IP address, and security groups, VPNs, all managed through Neutron. It is extremely powerful, but also honestly one of the most complex parts of the OpenStack to configure and troubleshoot. Next is the Cinder block storage. Cinder provides persistent block storage volumes for VM like virtual hard drives. This volume survive even if the VM itself is deleted. Cinder integrates with many storage backends, Ceph, LBM, NetApp, and ISC, Swift. This is the object storage. Swift is the open stack equivalent of Amazon S3. Distributed, highly durable object storage that scale horizontally to the petabytes, stores files, images, backups, and logs, anything. Then is the Glance, which is an image service. Glance is like a Catalog of VM template. Glance is like a catalog of VM template. When you want to launch a new Ubuntu VM or a Windows Server VM, Glance provides the image. It supports raw QCOW2 and the VMDK and the OVA formats. Then next is the keystone uh, identity and authorization or authentication. Every API call in OpenStack is authenticated through a keystone. It issues token, manages users, roles, and the domains, and enforces role-based access control. This is the security backbone of the entire platform. Then there is a Heat orchestration. Heat lets you to write OAML templates called hot templates that describes the entire infrastructure stack. One template can create a VM, configure network, attach storage, and set up auto-scaling. Everything here is automated. Then there is the horizon, which is the dashboard. The web-based GUI, non-client users manages VM, network, and storage quotas through a browser. Then there is a ceilometer, telemetry. Collect usage matrices across the entire cloud used for billing, alerting, triggering auto-scaling events. So these are the key components of the OpenStack, which have been we have been discussed in detail. So the next topic is in our agenda is strength. Strength over. Let's talk about why organizations chose OpenStack, especially for large-scale public cloud. There are six major strengths in the OpenStack. So let me show you. So this is the strength overview of the OpenStack. First is the zero licensing cost. Apache 2.0 license is free forever. No per core charges, no per VM charges compared to VMware or AWS. Organization reports saving millions of dollars annually. Massive horizontal scale. OpenStack doesn't just handle hundreds of servers. It handles hundreds of thousands. CARN operates over uh, 3 lakh crores on OpenStack. China Mobile run over 1 million crores. And this kind of scale is real and proven for OpenStack. Then the next is the vendor independence. No lock-in. You choose your hardware manufacturer, your hypervisor, a storage vendor. If you want to switch from Dell to HP or from VMware to KVM, you can do it without rebuilding your whole cloud from the scratch. So this is the massive advantage for the OpenStack. Then there is the full customization. Because it's open source, you can read every line of code, modify it, extend it, and patch it. You are not waiting for a vendor to add a feature. You can build it yourself. This is the fully customization advantage. And the hybrid and the multi-cloud review. The OpenStack APIs are compatible with AWS EC2 APIs. This means workload can move between OpenStack and the public cloud. You can build a hybrid cloud strategy. Thriving ecosystem. Over 30 integrated projects, uh, 1 lakh, 10 lakh plus contributors and the commercial support from Red Hat, Canonical, Mirantis, and SUSC. You are not alone. So these are the ecosystem of the uh, uh, OpenStack. Then the next is the strength one. We're going to detail discuss about the massive scalability. Let's go deep. The first and the most impressive strength, scalability. So if you look at the scalability, look at the chart on this slide. Real-world OpenStack deployment size ranges from 200 crores for a small private cloud, all the way up to 1 million crores for a hyperscale telecom, deployment. That range is very extraordinary. Not many platforms can say they work at both end of the spectrum. How does OpenStack achieve this scale? Several key mechanisms are working together to achieve this state. First is the horizontal scale. This is the most fundamental principle. Instead of making one server power more powerful, which has physical limits, you just add more servers. When you add a new compute node to the OpenStack, you simply register it with Nova. Nova immediately start using it for new VM placements. The cloud grows without any downtime. Nova filter scheduler. When your request comes in, lands a new VM, Nova doesn't just pick a random server. The filter scheduler evaluates every available host against a set of filters. Does it have enough RAM, enough CPU? It is on the right availability zone. Does it satisfy the affinity rules? This intelligent placement ensures workload are distributed efficiently and fairly across thousands of hosts. Then the next is the Nova Cells V2. When you have thousands of compute nodes, a single database and a message queue becomes a bottleneck. Nova Cell solves this by splitting compute node into the logical groups called a cell. Each cell has its own database and a message queue. This dramatically reduces the attention and allows the control plane to scale independently from the compute plane. Then there is the multi-region support. You can deploy OpenStack across multiple geographic regions, maybe one region in Mumbai, one in Frankfurt, and another one in Singapore, all sharing a single keystone identity service. Users can authenticate once and they can access resource in any region. Then there is a live migration. This is critical for operational efficiency. You can move a running VM from one physical host to another with absolutely zero downtime for the server. The VM keeps running throughout. This is essential for hardware maintenance. Instead of scheduling downtime, you just migrate all VMs off the server to your maintenance and bring it back. This is called live migration. Then there is auto scaling with Qt. Sheet templates combined with a shallow meter matrices enable automatic scalar. When CPU usage across a group of VM crosses threshold, say 80% for 5 minutes, Heat automatically launches additional VMs and adds them to the load balancer. When a load drops, it's scaled back in. This is elastic cloud computing, self-managed, like Amazon EC2 tool. So this is the strength one of our OpenStack. Now let's look into the open source and the cost saving. This is the open source and the cost saving. Let's talk about the money because this is often the primary reason organization chose the OpenStack over proprietary alternatives. The software license cost is zero. Apache 2.0 license per perpetually free and not a trial, not a premium model, fully free forever, including for commercial use. Compare this to VMware. VMware vSphere charges per CPU socket. VMware NSX, their networking component, charges additional per CPU. The licensing cost for a large VMware environment can easily run into millions of dollars per year. OpenStack eliminates this entirely. Look at the cost breakdown on the chart and the pie chart on this slide. With the OpenStack, your cost of hardware, example CapEx and operation OpEx, and in networking. This software license slice is essentially zero. Compare that VMware or proprietary cloud where the software licensing can be 30 to 40 percentage of total spend. Organization consistently report 40 to 60 percentage of total cost of ownership total cost of ownership reduction. Okay. Uh, then compared to the equivalent VMware or AWS private cloud deployments. And there are commercial options if you need enterprise support. Red Hat offers a Red Hat OpenStack platform, RHOSP. Canonical offers Charmed OpenStack, and Mirantis and SUSC also offers supported distributions. So you get the cost benefit of open source with the safety safety net of commercial support. One more important point, you have 100% access to the source code. You can audit for security vulnerabilities. You can patch bug yourself without waiting for the vendor. Now next is the flexibility and the rich ecosystem. These are the flexibility and the ecosystem of our OpenStack. First is the hypervisor. KVM is the most common and the most tested, but OpenStack also supports Xen, VMware, ESXi through a Nova driver. You are not forced into one hypervisor technology, so there are multiple options. Then there is storage backends. The recommended storage backend is Ceph, a distributed open storage system that provides block, object, and the file storage all in one. But OpenStack also works with NFS, ClusterFS, and the NetApp, OnTap, Pure Storage, and the Dell EMC. If you already have a storage investment, OpenStack almost certainly integrate with it. Then there is the network driver. This is the native option in OpenVSwitch with the OVM. But OpenStack also supports Calico for Kubernetes, style BGP networking, Cisco ACI, and Nexus for enterprise data center networking. Uh, Even VMware NSXT. You can keep your existing network fabric. You don't have to put new networking plans. Then there is containers and the PaaS. OpenStack has grown well beyond just VMs. Magnum deploys and manages Kubernetes clusters on the top of OpenStack infrastructure. ZUN provides a bare container API. Trove gives a database as a service. Octavia provides enterprise-grade load balancing. And the Moarana provides an application catalog. And this ecosystem means OpenStack can serve as the foundation for not just virtual machines, but a complete cloud platform, including containers, databases, and managed applications. Then we go to the limitations. Limitations of our OpenStack. These are the limitations. Let's completely honest. OpenStack is powerful, but it is not that easy. There are serious limitations that every organization must undergo before committing to. There are three high severity limitations. Steep learning curve. OpenStack requires expertise across Linux administration, software-defined networking, distributed storage, Python scripting, and the cloud architecture, all at once. Finding engineers who know all of this well is genuinely difficult. Onboarding a new team member takes months, not weeks. Complete upgrade process. OpenStack releases a new major version every 6 months. Each version goes end of the life after about 18 months. Upgrading between major versions is very painful. It requires careful staging, testing, and database migration and coordinated restart across all services. Many organizations fall behind on upgrades and accumulated technical debt. Many organizations fall behind on the upgrades and accumulate technical debt. Then large operation teams needed. A production OpenStack cloud doesn't run itself. You need a dedicated team of 5 to 15 site reliability engineers minimum. These are the specialized, expensive engineers. For smaller organizations, this operational cost alone makes OpenStack very impractical. Three medium severity limitations. First is the network complexity. Neutron is the more powerful but notoriously difficult to configure and troubleshoot. Virtual networking involves namespaces, OVS flow tables, and VXLAN tunnels. layer upon layer of abstraction that are deeply opaque when something goes wrong. Component maturity gap. Core services like Nova, Cinder are very mature and stable, but peripheral projects like Motor and Magnum are less stable and less well documented. You may encounter rough edges. No fully managed options. With AWS or Azure, you pay someone else to manage the platform. With OpenStack, the management and responsibility is entirely yours. There is no OpenStack as a service that takes away operational burden. So these are the limitation overview. So let's go deeper into the complexity and the operational overview. Look at the deployment timeline on this slide. A greenfield OpenStack deployment from scratch takes infrastructure planning 2 to 4 weeks. Operating system and network setup 1 to 2 weeks. And OpenStack installation is 1 to 3 weeks. And component configuration is 3 to 8 weeks. Testing and hardening 2 to 4 weeks. That's 9 to 21 weeks minimum, roughly 3 to 6 months before you have a production ready tool. And with an experienced team, inexperienced teams can take much longer. Server dependencies. Every OpenStack service, Nova, Neutron, Cinder, Glance, Keystone has its own configuration files, its own database, and one connection to RabbitMQ, which is the message queue. A misconfiguration in one service can cascade failures across the entire cloud. Debugging this requires understanding how all service interact. Then there is neuron complexity. Virtual networking involves namespaces, so deeply opaque to the debug. Then debug and logging. Logs are scattered across Nova, Neutron, Cinder, and RabbitMQ. Configured drift. Without IUAC, nodes drift over time. Staffing cost. Hiring qualified OpenStack engineer cost up to $130K to $200K per year. Typical clouds need 5 to 15 engineers minimum. So this is the limitation one. Then the upgrade and the challenges, we look into them. The second major limitation that catch organization off guard is the upgrade. And this one is really hurts in practice. OpenStack releases a new major version every 6 months. Each version is supported for approximately 18 months before it reaches end of the life and stop receiving the security patches. This means you are under constant upgrade pressure. You must upgrade at least once a year to stay on a supported version. Look at the upgrade duration chart. A patch level upgrade might take 1 day. A minor upgrade might take 4 days. But a major version upgrade minimum deployment can take 14 days. And major release can take, which is a large deployment for 45 days. Example, Yoga 2. For a full upgrade and with the testing, it requires 90 days. Why is upgrading so painful? Because no in-place upgrade for many services. Database scheme migrations, RabbitMQ pinning, staging environment is required. Rollback is nearly impossible in this life cycle. So these are the upgrade challenges which has been faced during the use of OpenStack. Then we look into the real-world large-scale deployments. So these are the real-world large-scale deployments. First is the CERN. CERN, which has 300K cores. CERN is the European Organization for Nuclear Research. It runs the Large Hadron Collider, the world's largest particle accelerator. Data from particle collision experiment is enormous. CERN uses OpenStack to run approximately 10,000 virtual machines daily across two sites, Geneva, Switzerland, and Budapest, Hungary. They built multi-region federation, so both sites work as one unified cloud. If send trust, OpenStack with physics data that took billions of dollars and decades of work to generate that says something remarkable about its reality. AT&T, Telecom MFT, used to OpenStack to implement network function virtualization MFT. Then there is China Mobile, 1 million plus cores, and there is Walmart, petabyte scale, and Nectar, 40,000 plus cores, and the SAP and the BMW. The common thread across all this deployment, large organization with skilled engineering teams, long-term investment horizons, and a need for customization fund. That's a sweet spot for OpenStack. Then there will we can see the comparison of OpenStack versus competing platforms. So these are the comparison. So if we see the criteria, license for OpenStack is Apache 2.0. Initial complexity is very high. Scalability is hyperscale. Customizability is full. Open source. Vendor lock-in is managed option. Limited vendor. Community size is massive. 100K. Telco and the NFV use industry standard. So that's why the OpenStack is used by many organizations rather than this proprietary software. Then we look at the best practice for public cloud success. So these are the 6 things we need to do. Use a validated distribution. Deploy Red Hat OpenStack platform or canonical Django OpenStack for enterprise grade support and security uh, backprotecting. Then use automate everything with infrastructure as a code. Particularly use Ceph for the storage. Monitor from day one. Deploy Prometheus plus Grafana OpenStack exporter. And plan upgrades proactively. Design for multi-tenancy from the start. So let's look at the summary and the strategic conclusions. So these are the summaries. Uh, on the strengthened side, zero software cost scales to 1 million plus cores, fully open source, no vendor locking, a rich ecosystem, 30 plus integrator projects have been developed, multi-hypervisor, multi-storage support, hybrid multi-cloud via compatible APIs, world-class community and commercial support. This is best for organization with engineering teams, long cloud investment horizons, and a high speed for customization. And the limitations are very steep initial learning curve, upgrades are complex and time consuming, requires large skilled ops team 5 to 15 plus, and the neutron networking is notoriously tricky, and component maturity varies widely. No fully managed public cloud offering. Long deployment time, 3 to 6 months. These are the limitations of the OpenStack. So these are the analysis of OpenStack for large-scale public cloud. So this is the limitation and the strength of the OpenStack. This is best for the organization with skilled engineering teams, long cloud investment horizons, and a highly need for customization and control. So this is the presentation on my OpenStack analysis. Thank you.